Is there another planet in our solar system? Well, no, not you, Pluto. Go away. Anyway, this presentation is summarizing the paper titled New Extreme Trans-Neptunian Objects Toward a Super-Earth in the Outer Solar System. In 2003, the first extreme trans-Neptunian object, or EDNO, named Sedna, was discovered. And in 2012, another EDNO named 2012 VP113 was found. Immediately, people noticed a peculiar thing. Their longitude and argument of perihelia are very similar. However, the author of the second paper noted that this object was found in a similar fashion as Sedna, so this could just be a coincidence, and further investigation is needed. Since then, many more trans-Neptunian objects were discovered, and it seems more and more likely that there is a clustering effect. However, we still need a more statistically rigorous analysis to show that the objects are actually clustering. And that is what the survey is aiming to do, find more EDNOs to get a more robust evidence of the clustering effect. But before we get into the survey result, why do we even care if there's a clustering effect? It's because of the implication about our solar system that comes from explaining this effect. One of the explanations was that while the protosun was still in its birth cluster, another protostar was close enough that it perturbed the orbits of EDNOs to what they are now. Another explanation was a rogue planet came and disturbed the outer solar system to cause the clustering. However, it was shown later that if the perturbation were an isolated event, and is no longer present in our solar system, the clustered objects would have rescattered into random distribution. This suggests that the force causing the clustering phenomenon is likely to still be present in our solar system. This leads to a popular theory. Maybe there is another planet beyond Neptune orbiting the Sun, shepherding these EDNOs, stabilizing them into the clusters. If we can find more EDNOs, then in addition to showing the clustering effect is statistically significant, we can also narrow down the possible orbital parameters of the hypothetical planet 9. In this survey, they discovered 54 objects, with 46 of them having reasonably accurate orbital parameters. Some of the interesting objects found in this survey include an outer Oort cloud object with perihelion higher than Neptune. This is the first time we've ever seen an object like this. Another object of interest has a high inclination. Normally, EDNOs have inclinations around 20 degrees. However, this object has an inclination of 48 degrees. This suggests that it's likely being affected by the Kozai mechanism, potentially caused by either Neptune or the hypothetical planet. There are also a few EDNOs that seems to be in a higher order resonance with Neptune. Most of the EDNOs that are in resonance with Neptune has a resonance ratio of either n/1 or n/2. These objects are in the n/3 ratio with Neptune. In addition, these new discoveries also allow us to update the population statistics of different families of the Trans-Neptunian objects. But more importantly, there are many EDNOs discovered in this survey that are in the arguments and longitude of perihelia cluster. The top row here shows the arguments of perihelia, and the bottom row shows the longitude of perihelia. The left column here is for objects with perihelion distance greater than 35 AU, and the right column is for less than 35 AU. First, let's look at the arguments of perihelia. For EDNOs with perihelion greater than 35 AU, the arguments of perihelia cluster between 290 and 40 degrees. For objects with perihelion less than 35 AU, they cluster between 100 and 200 degrees. It's worth noting here that Neptune has a significant influence on objects with perihelion distance shorter than 40 AU. However, since the clustering effect starts from 35 AU, this suggests that the planet 9, if it exists, has a stronger effect on these EDNOs. However, it's also worth noting that planet 9 hypothesis cannot explain the clustering of objects with perihelion less than 35 AU. Next, let's look at the longitude of perihelia. There is a less significant clustering effect occurring. However, there is a strong correlation between the arguments of perihelia and the longitude of perihelia. Objects with arguments of perihelia between 280 and 360 degrees have longitude of perihelia between 0 and 130 degrees. Objects with arguments of perihelia between 0 and 40 degrees have longitude of perihelia between 180 and 340 degrees. Wait, I hear you ask. What if it's just a coincidence that we happen to see those objects and there actually wasn't a clustering effect? To avoid that possibility, the authors of this paper developed an observational simulator to see what is the probability of getting this result if the EDNOs are distributed randomly instead. For observing the arguments of perihelion clustering, the probability of this happening by chance is less than 0.1%. For the longitude of perihelion, it's less than 0.2%. So now that we've established the clustering effect is statistically significant, can we say that Planet 9 really exists? Nah, not really. There is, however, another circumstantial evidence for the existence of Planet 9. Here are 4 of the known EDNOs and 2 newly discovered EDNOs, and their semi-major axis and orbital periods. Using an estimate made by a previous paper, these EDNOs would all be in mean motion resonance with P9. Although, as you can see, the resonance ratios for the 2 new objects are a bit dubious. These are all circumstantial evidences though, and there is no direct proof. A conclusive proof of the existence of this planet would be if we actually found it and get an image of the object. Which brings up an interesting question. Why haven't we seen this planet, even though it's so massive that it can affect a whole population of objects better than Neptune? The answer lies in distance. Because of its orbit, even at its hypothetical perihelion, there is still a 200 AU distance between the Sun and Planet 9, making it a very faint object to begin with. Furthermore, its hypothetical aphelion is more than 1000 AU. This highly eccentric orbit suggests it spends the majority of its time near aphelion, making it even harder to detect. In fact, the observational simulator predicted that the probability of detecting this object is less than 1%. In conclusion, this paper offered many evidences on the existence of this mysterious Planet 9. However, there are still many holes in this hypothesis. How can we explain the reverse clustering of objects with perihelia shorter than 35 AU? Is it possible that the mean motion resonance is just a coincidence? How can this planet fit into the current understanding of solar system formation? And finally, we don't have any direct proof that the planet exists. If these questions can be answered, then this hypothetical planet is more likely to exist, and that would allow us to gain an even more profound understanding of our solar system.